All right, so let's take a look at this molecule. All right, so PCl3, first thing we're going to do, we're going to count how many electrons we have available. So phosphorus is in group 5, so it's 5. And then each chlorine is in group 7, so there's 7 electrons multiplied by 3 atoms. So it's 21 plus 5, which would be 26 electrons. All right, so then now I'm going to find my needed electrons. So phosphorus likes to have 8. It's not an exception. So does chlorine. And there are 3 of those. That's 24. So it's going to be 32 electrons that are needed. So now 32 minus 26 should give me 6 electrons. All right, so now divide that by 2 because each bond is 2. I'm going to get 3 bonds. So I should have 3 bonds in this molecule. All right, so phosphorus is in the center. It's this only singular atom, so chlorine around it. I'm going to make single bonds between each phosphorus, between each chlorine and phosphorus. All right, so now I am going to add my extra electrons. So I've made 3 bonds. I've got 20 electrons left over, so I'm going to distribute them to the outside atoms. So 2, 4, 6, 8. Chlorine wants to have 8, so I can move on. 2, 4, 6, 8. Move on. 2, 4, 6, 8. Move on. All right, so now if I count the electrons, I've got 2, 4, 6, 8 around each chlorine. So that's 24 electrons, so I've got 2 left over. So when I have leftover electrons after I've distributed to the outside, I'm going to add a lone pair to the phosphorus atom. So phosphorus has a lone pair right here, and then 3 bonding pairs. And now I can check, phosphorus is now satisfied. It's 2, 4, 6, 8, and every chlorine has 8, and I've used all my 26 electrons. All right, so let's look at another one. All right, so HCN. All right, so first thing, let's count our available electrons. Hydrogen has 1. Carbon has 4. It's in group 4A. And nitrogen is in 5A, so it has 5. So that means I have 10 electrons available. All right, so hydrogen is an exception. It wants to have only 2 electrons. Carbon likes to have 8, so does nitrogen. So I have 18 electrons needed. So 18 minus 10 give me 8 electrons that are going to be shared, and each bond is 2. So I'm going to make 4 bonds here. All right, so when I look at this, I need to decide what goes in the center. Well, hydrogen will never, ever, ever go in the center. So really, it should be the least electronegative, which would be hydrogen, but hydrogen can only make 1 bond. It only wants 2 electrons, so it will never go in the center. It will never make more than 1 bond. So your other options are carbon and nitrogen. Well, technically carbon is the least electronegative, so it should go in the center, but also if carbon is in your molecule, it usually goes in the center because it likes to make 4 bonds. So carbon will be in the center here. So now I'm going to make 4 bonds. So I'm going to make a single bond here, single bond here. So now I need to decide where the other bonds go. Well, I cannot put them with the hydrogen because hydrogen only likes to make 1 bond. So that means I can put them in between the carbon and the nitrogen. So I have 3 bonds, now 4 bonds. So I'm going to make a triple bond in between the carbon and the nitrogen. Never, ever, ever should you have a double bond or a triple bond on a hydrogen. All right, so now I've made my 4 bonds. So now I'm going to count my electrons. I've got 2, 4, 6, 8. I've got 2 left over. Carbon is satisfied, so is hydrogen, so the leftover 2 will go on the nitrogen like this. So I've got 2, 4, 6, 8, 10. So now I've got my 10 electrons, everything's satisfied, I can move on. All right, so let's do phosphate. Phosphate has a charge, so that means my needed electrons will be different. So, or my available electrons will be different than normal. So phosphorus has 5 electrons. It's in group 5. Oxygen has 6. There are 4 of those, so it's going to be 24. But because we've got a negative charge here, that means we've got more electrons than we should. So a negative charge means you have more electrons. A positive charge means you have less electrons than you should. So I have -3, which means I have an extra 3 electrons here. So that means I have 29, I have 32 electrons. All right, so now let's figure out how many bonds I'm going to make. So phosphorus likes to have 8. So does oxygen. All right, so 40. You need to have 40 electrons here. So 40 minus my 32 would give me 8 electrons being shared. So now divide that by 2, you get 4 bonds. All right, so now the phosphorus will go in the center because it's a singular atom here. All right, so now we're going to make single bonds between each of the oxygen atoms and the phosphorus. So that's 4 bonds right there. Well, I've got 32 electrons. So now I'm going to distribute to the oxygens. So 2, 4, 6, 8, move on. 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 All right, so now I've got 8 on each oxygen. So 8 times 4 would give me 32 electrons. So I have 32 electrons used, and oxygens are satisfied, so is phosphorus. 2, 4, 6, 8. So now all I need to do is just put brackets around it with the charge. So if you have a polyatomic ion or a molecule with a charge, you just put brackets around it at the end and add the charge. So the main difference here is that when you figure out the available electrons, you actually have 3 more electrons available. That's the main difference between a molecule with a charge and just a regular molecule. All right, so let's look at another one. All right, so carbon chains. You are going to see some hydrocarbons, and you will have to come up with a structure. So if you have a hydrocarbon, which is a molecule with carbon and hydrogen on it, you're going to have multiple central atoms here. So the carbons will essentially create a chain. So if you've got more than one carbon atom, you're going to make a chain of carbons like this. So I've got 1, 2, and then I've also got an oxygen. So I'm going to have 2 carbons in the center. And then you're just going to put your other atoms around it. So I have a hydrogen here, 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 here. And then I have another oxygen atom here attached to an H. And then this actually shows you what the structure should look like. The carbon here is bonded to 3 hydrogen atoms. The carbon here is to 2. And then also there should be an OH group at the end. All right, so now, even without counting the available and the needed electrons, what you can do here is you know that carbon likes to make 4 bonds. Hydrogen will always make 1 bond. So using that alone, I can figure out where my bonds will go. So I'm going to have single bonds between the hydrogens here and the carbon here. Another single bond between these 2 carbon atoms. Bonds here, a bond here, and here. So I have 4 bonds on this carbon, so it's 1, 2, 3, 4. On this carbon, I have 1, 2, 3, 4. And then right here, I have an OH group. All right, so now let's figure out how many electrons I actually have. So carbon has 4 electrons. There are 2 of them, 1 here, 1 here. So it's 8. I've got 3 hydrogens here, 2 here, 1 here, so it's 6 hydrogens. And each hydrogen has 1 electron available. And oxygen has 6. So it's going to be 8 plus 6 plus 6. So it's going to be 20 electrons. All right, so now if I count, I've used 2, 4, 6, 8, 10, 12, 14, 16. I have 4 electrons left over. Well, oxygen is still not satisfied, so we will put the rest of the electrons on the oxygen. So 2, 4, 6, 8, satisfied now, and I've used all my 20. So when you have things that are like this, or 8. Okay, if I have something like this, I know that I'm going to have a chain of carbons here. So anytime that I have something like that, I'm going to have a chain of carbons. So let's go ahead and do this one really quick. So I have 3 carbons, so those will go in the center, and then H's all around. All right, and then I've got 2 left, so 1 here and 1 here. So now I can just make my bonds. So 1 here, 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 bond the 2 carbons, then bond these carbons, and then bond the hydrogens here. So now I've got carbon with 4 bonds, 1, 2, 3, 4, and hydrogen only has 1, 1, 2, 3, 4 for this carbon, and then 1, 2, 3, 4 for this carbon. So then that would be my structure for that.